and then hopefully we'll have this one.
So what some place scenario, it's just one party per person. So you can record anybody you want. But what is the most?
I don't know. In South Africa, you just have to, well, as far as we've been told, you just have to tell the class that you're recording the class. Yeah. So I've declared it. Okay, so we'll move on. So now I said to you yesterday that the way they make these mass spectrometry pictures is now, how do I get rid of that bar? Oh, it's so annoying.
So you click on that, the second one on the right side.
The second one on the right in my taskbar. There.
Next to WhatsApp.
Okay, next to WhatsApp, I click there. There. Well done. Well done. Okay, so now we've got laser pointer. Right. So what they do is they've got a device like this. Okay. The stuff that they want to analyze, they put in the sample. Okay. So the substance, whatever the element is, or the molecule, you can do it with molecules as well. You put the sample in there, all right, and you enter it into this tube. Now, this tube is essentially evacuated. It's got no air. It's a vacuum tube. So if you have a sample in this little container over here, and you open the lid, and because this is a vacuum, some of the sample will go in there. You agree? Right. Now, as soon as it comes in here, over here, you have a little electron gun. It says electron beam source. So you're shooting electrons from the bottom here up to the top. Now, how do you do that? There's all sorts of ways of doing it, right? Don't worry about how they do it. They just shoot electrons through. The sample, when it comes in here, is heated up by a heater, and it turns the sample into a vapor. So now you've got vapor of molecules or atoms of the sample, which are being bombarded by electrons. What those electrons do is they knock electrons out of the atoms or the molecule. They bombard those electrons with the electrons they're shooting with have got just enough energy to knock one electron out of the atom or the molecule. Normally not enough to knock two or any more, just to knock one out. Okay? So some of the atoms have one electron knocked out of them. Next to that, they've got two plates. And these two plates, it doesn't show you here, but these two plates are connected to a positive and a negative, so that they attract the electrons. They attract these charged particles. These particles now got charged because they were smacked by electrons. So here you've got particles that get smacked by electrons. They're vaporized. They're now ionized. They're attracted to this plate. They shoot across to that plate, but the plate's got a hole in it. So they shoot across to the plate because the plate's positive, let's say. They go through the plate, and these two electric plates accelerate them even faster. Okay, so now they make the ions move really fast through this tube. Does that make sense? So these electric plates accelerate them. So that's the accelerator. Now they go here, and now they put very powerful magnets around the tube. And when charges move through a powerful magnetic field, they get a force at 90 degrees to the direction of movement. So now they bent. If they all have the same charge, they get the same force. But if they're heavier, they won't be bent as much. So that's why they spread out into different beams. And then they have a detector here that just picks up how many particles hit. Make sense? So there are the various parts. There's ionization, acceleration, deflection, detection. I'll come to you in a second. This is actually A level. These details will be in, it's not in the AS level, it's in the A level, but it just helps to explain where these graphs are coming from. You had a question?
Between strokes will be the same in the ion state.
Is in the particle state, yeah. No. No, yeah, exactly. Right, so that produces those graphs, and each of these lines represents one particular ion, like we said, with their relative abundance. It's pretty easy to work out the height or the amount of the one ion and the amount of the other one. All right. This is just a little bit more detail. You can see as the particles come out, a bit more detail about the analysis. You can see the different weight particles. So 20, 21, and 22 would come out of slightly different places. Heavier particles will be deflected less. And then you see here it says that the radius of the path depends on the mass to charge ratio. So obviously over here in the graph, you can see you've got, a split of the two different mass ions. But if they had picked up a 2+ charge, you'd get exactly the same ratios, but it would just be at half the MZ value. And if you get a peak at half the MZ value, you know that's because you had some 2+ ions. But we just ignore those. Happy? All right. So now we'll move on back to where we were. And I think we got past Avogadro's number, past moles and particles. Yeah, so, but your slide's got a different number to mine. So I think we did the mass conservation. Did we finish this one? Yes, we did. We did that. And I even showed you this. Did we do this example? No, I asked you to do it for homework. Did you do it for homework? Ah, give me an answer. Shout. How much? NO2. I haven't got the answer, but I know NO2 is right. Okay. Anybody need me to do that? No? Okay, good. We got onto this. I explained that little thingy, and we got onto neutral atom. That's where we got to. Right. So I said to you that this symbol has got two meanings. It's oh yeah, we got past there. We got to here. And I spoke to you about the fact that the mass number now has two meanings. It's the number of protons and neutrons, plus it's the relative atomic mass, or the mass of 1 mole. And this slide is basically saying the same as this slide. It's just pointing out that the 23 means it's either 23 nucleons or 23 grams per mole. And I'll do the same thing for calcium. Calcium either has 40 protons and neutrons, or you can say 1 mole of calcium has a mass of 40 grams. Right, let's do some examples. Do that one. Giving you the formula. Do it on the page, or you can do it on paper if you want to. Calculate the number of moles of water that would have a mass of 100 grams. In 100 grams of water, how many moles do I have? Answer?
1.66, yes.
We agree. Now, I've put 3 ticks on that because in the NSC level, that would be worth 3 marks. AS level? Mr. Dialgo.
You can see you have to use the color, but now the data was the full chart.
I don't know. To be honest, so look, all my years of working in the UK, we use decimal points. Then I come to South Africa, it's decimal points, and then all of a sudden now everybody's using commas. I never heard anything official that said, oh, now it's decimal points or commas. I've stuck to decimal points because I actually do my calculations in a spreadsheet, and my spreadsheet is set up for decimal points, and I'm not going to change it because if you see my spreadsheet, you'll understand why. So I just refuse to change it. Mr. Robertson, every time I set an exam paper, moans like anything and makes me change all my decimal points to decimal commas, which really annoys me. But apparently in South Africa, that's what you're supposed to do. I don't know, to be honest. And if you send me a Teams message, I can check, and I probably should. What is Cambridge going to do? I don't think they'd mark it wrong, but we probably better know. So send me a Teams message, and I'll look into it. Okay. For now, I don't mind. All right. Now, I spoke to you about reactions. So look, this is my little way of doing it. We're going to give you a question, and I've been through that other layout with you, where I explained how these things work. We're going to give you some information. You're going to be given some information, and you're going to be asked some information. So in this question, we are giving you, we're telling you you've got 46 grams of sodium, and we are asking you what mass of hydrogen would be formed. Now, last year you probably taught how to do this, so you might actually be able to do it. All I want to point out here is every time you do these, you use exactly the same method. There's the steps. Those are the steps that you use to answer every single stoichiometry question. So, if you understand those steps, you should be able to get them all right. Can you guys do that, or do you want me to take you through it? Think you can do it? Go for it. You thinking out loud or actually asking me a question? Are you thinking out loud or actually asking me a question?
The next slide, let's suppose the answer is 2.
We'll see. We'll see. We'll get there. I'll just give people time to do it. The same 4 steps will give you the correct answer in any stoichiometry question. Peter, were you absent? Were you absent? Not.
I've got content and I'll just do on the second hand profession one. So there you go, you know.
All right. Is everybody there? Okay, so what's the answer? 2. Is it 2 grams? So you balance the equation. You worked out the moles was 2 moles. You worked out the molar ratio of hydrogen to sodium, and the molar ratio of hydrogen to sodium is 1:2 or 2:1. So you get 1 mole of hydrogen formed, 1 mole of hydrogen weighs 2 grams. Yep.
Yeah.
Did I?
Doesn't have the 82.
Yeah.
Slide.
So that doesn't.
The slide after this one. Okay, we'll get there in a minute. Let's just stick with that slide. Any problems on that side? Sure. Okay, so you're all happy with that. Now, are you telling me that the yeah, no, so it's asking the mass of, so when it says what mass of hydrogen is formed, I should have said the question is not quite clear. It should say the mass of hydrogen gas. So 100% agree. This question should have said, yeah, let me go back here. I should have said, what mass of hydrogen gas, what mass of hydrogen gas would be formed? Okay. Well, no, because that hydrogen, yeah, then it's ambiguous. Then it's a bad question. Now this question here, I've just put that in there because some people just like to say, okay, I want to cross multiply or whatever. It's not really cross multiplying, but you know, there's 2 moles of sodium for every 1 mole of oh, that one hasn't got the hydrogens on. I see what you're talking about. But if you're talking about moles of water and moles of sodium, there's 2 moles of sodium for every 1 mole of water. Now, if you want to work out the number of moles of sodium equal to the number of moles of water, therefore you multiply the water by 2. Okay. If that throws you at all, then come and see me. Anyway, so we seem to be all happy with that. Right. So you must be able to do those, but you must be able to do them irrespective of if we ask you masses or whatever. Okay, now we need to understand a little bit about hydrated salts. Now, I don't think you did these last year, right? You may have seen copper sulfate. Any of you seen copper sulfate before? Copper sulfate, it's a lovely blue color, right? So I'm representing this here as a pile of copper sulfate. It's a lovely blue powder. Now, if you take copper sulfate and you heat it, then it goes white, right? Kind of the same as if I heat you up. Well, you go red actually, but if you're not happy with it, you might go white after a while. Your face might go white because you drive the water off it. And when I got to the school, they used to do the dark. And I stopped them very quickly because what they did was they used to, the science teachers had this little experiment they used to do with the grade 8s or the grade 10s, whenever they did this thing. They would, so this copper sulfate over here that has had its water driven off, it's called anhydrous copper sulfate, and it's white. Now, they'd put a pile of anhydrous copper sulfate on a person's hand, and then they drop water on it. What happens? Turns blue, and it gets hot. Why did it get hot? Well, it's endothermic over here. When you drive the water off, you have to add heat. So it's endothermic, which means the reverse process is exothermic. When you drop water on white copper sulfate, it gives off heat. And this thing, they drop water on it and get hot. Now, you do that to grade 10s, little boys standing here with their mates. What are they trying to do? Okay, we're going to hold it down. The next day, they come to school and got a big flipping blister in the middle of their hand. Health and safety. Yeah. So, look, I taught in the UK for 13 years, and health and safety is like front and center. You don't touch any chemicals in a lab, ever. So I stopped that process very quickly. Anyway, if you heat up 1.6 grams of water of copper sulfate, you're going to get some water off. How much you're going to get off? You think you guys can work it out?
Yeah.
Have a go. Have a go. You've got an equation there, CuSO4.5H2O. This is actually the formula of copper sulfate. That's the formula. Because every time you get one copper sulfate molecule, that's not really a molecule, but every time you get one of those, you get 5 waters trapped. And if you're driving them off, you can imagine how many waters there should be here. You need to balance the equation. So try and do that quickly. Work out for me how many grams of water would we expect to get if we heat it up. 1.6 grams of copper sulfate .5H2O. What mass of water would we get? Nice little exam question. If you don't know where to start on a chemical calculations question, work out moles. Just go through those four steps. Work out the moles of the thing that you're given. Then go through the molar ratio to look at the moles of the thing you asked. Then work out the quantity you've been on.
Question how much mass?
Yep. How many grams? Come see you. Oh, you are typing. No, I just thought you weren't typing. So that full stop, gentlemen, in this formula does not mean multiply. Yeah. Doesn't mean multiply. It just means there are 5 there. Okay, got some answers? Daniel, you got an answer? Almost. Anybody agree with 0.8? Yes or no? Now they sound like they're not sure. No? What did you get? 4.58? Oh, okay. Fine. You're allowed to make mistakes in my class. I got 0.6. And the reason I got 0.6 is that 0.577. What are the steps? Well, I first worked out the number of moles of what I was given. Okay, this is the moles of what we were given. We were given 1.6 grams of copper sulfate. There's copper sulfate's molar mass. The formula is mass over molar moles, molar mass. That many moles of copper sulfate, 0.5H2O. Therefore, we'll go through the molar ratio. One of these equals 5 of those. So the number of moles of water is 5 times the moles of copper sulfate. So I'll multiply that 0.00641 by 5, gives me 0.0321. And then I'm going to look at the mass of water using number of moles times molar mass times 18, 0.577. Yes.
That's crystallized inside the copper sulfate. Why did we multiply the moles by 5? So usually.
The reason is because
I think I saw them with big mini movers. Yes, sure, we did. Someone there at the start of the
Yeah, so the reason you multiply by 5 is every one of these, every one of those units gives you 5 waters. So it's the ratio of those units to water.
What's inside of the salt bin?
Yeah,
So,
yeah, because I need the mass. No, I need the mass of this whole unit. So this mass of the whole unit is all of those added up plus 5 of those. Yeah, because now we're just working out the molar mass of H2O. Happy? Yes, yes, you can do it. All right, happy with that? Yes? Good. Now, molar volumes. You probably have discussed molar volumes. What is the molar volume? Have you done molar volumes in grade 10? Yes, you did. All right, so you won't need this discussion. Are any of you confused at all about why it is that all gases have the same molar volume, even though they're different sized particles? Okay, so let me go through this. So what's that? That is a picture of 2 rugby teams, okay, from the sky. And the one on the left is like the under 15 D team, and the one on the right is the first team. So the guys are bigger, you agree? Now, the area taken up by the scrum, would you say the area taken up by the scrum of the first team is bigger than the area taken up by the scrum of the under 15s? Yes. Okay, because the particles are bigger, they're right next to each other, so they take up more space. But would you say that the area taken up by the backline of the first team is much bigger than the area taken up by the backline of the under 15s?
it's
Pretty equal. How come? Because there's a lot of space between them. And so the increase in size of the person doesn't increase the size of the backline. See what I'm saying? Because the particles are further apart. Right? So gases, because their particles are far apart, you know that from grade 8. If the particles are a little bit bigger, it doesn't mean the gas occupies more space. The space it occupies has got to do with how fast it's moving, not how big the particles are. But when you push them together in a solid, if the particles are bigger, then they do occupy more space. Make sense? So any gas, doesn't matter how big its particles are, occupy the same volume as any other gas. It's the temperature and pressure that affect its volume, not the size of the particle. Does that make sense? Yes? Words come to school today. So 1 mole of any gas occupies exactly the same volume. Doesn't matter what gas it was, if it's at the same temperature and pressure. And that is 22.4 decimeters cubed. And if you didn't know that, by the way, how big is 22.4 decimeters cubed?
oh, that's so
Yes. That big. So exactly it's okay. Now, 22 liters. Is a decimeter cube is a liter. I mean, I'm telling you that 22 liters will fit in. You think 22 liters of milk will fit in here? Actually, they will. If you see those liter, have you ever seen those liter containers that are actually square? Most liters of milk are not square. They're about this tall, they're only about this wide. But if you get a liter, a container of milk that's actually square, then it's only like this. And you could fit 23. So that's the volume of any gas at standard temperature and pressure. Now, obviously, you need to know what standard temperature and pressure are. What are they? Well, standard temperature is 0 degrees Celsius or 273 Kelvin. Standard pressure is 1 atmosphere or 101.3 kilopascal. The actual values you can use from your data sheet. If you need them, they'll be given to you in your exam paper. Okay. We've got a little formula then, which comes from that statement, and that formula is number of moles is volume over molar volume, and the molar volume is always 22.4. So now we've got another amount that we can give you in order to give you the amount of something. So I can ask you a question like this. Now, you probably did some of these last year. So try and answer that one quickly. Start putting done. Good shot. Done? Didn't now.
Already done.
Oh, is it already done for you?
No.
Is it?
Yeah.
No, I didn't say that. I said start when you're done. Check me. Start when you're done. You must write them and sit down. I don't want you to do it in your head.
Oh, it's around.
Yeah, but you must have it. That's not good. You should not have to look in the problem. You can look competitive, you don't like the lesson. Otherwise, I'm actually laughing at it. But that's going to have to be it for today. You all got the answer. Okay, so I'll give you, we'll look at the answer next lesson. Thanks, chaps. We'll see you tomorrow. Yeah. Thank you, guys. Cheers.